This talk is about diffusion MRI for brachial plexus injuries. Traumatic injuries to the plexus are uncommon, but they're devastating for patients and costly for the health service. Surgeons are interested in identifying patients with root avulsion, or at least differentiating this injury from postganglionic injuries. That's because they're the most prevalent form of injury, and they require early nerve transfer. So to facilitate early reconstructive surgery, early imaging is often done, but conventional MRI like this offers only modest diagnostic accuracy, which simply isn't good enough. And to qualify that statement, I refer you to our paper in radiology. That's why, in Leeds, we've been experimenting with diffusion techniques for several years. Water in a vacuum diffuses randomly, isotropically. But the human body's not a vacuum. It's full of spaces, compartments, pipes and tubes. And this is particularly so, and particularly important, when it comes to nerves, where the diffusion of water is principally bidirectional. It goes up and down the nerve, staying within its respective compartments and rarely strays. And we can exploit this phenomenon using diffusion MRI. Here's a regular MRI of a nerve. It's an artistic impression. There's a branch coming off. If we resample this slice using diffusion sensitizing gradients many hundreds of times, then we can build up a 3D vector of the movement of water. That's called a tensor. Long, thin tensors imply water moving bidirectionally up and down the nerve, as we would expect. Spherical tensors imply isotropic diffusion, chaotic, as you might see in the connective tissue around a nerve. And we can join up highly anisotropic neighboring voxels using lines or tracts, and we specify a number of conditions to make sure the image doesn't get too chaotic. That allows you to build up 3D reconstructions of nervous tissues like this, which is a traptogram of the spinal cord and brachial plexus in a healthy adult. And just remember that every pixel in this image contains detailed information about the 3D movement of water, i.e. its microstructure. We've shown that this technology is sensitive to chronic root avulsion, whether it's 1, 2, 3 roots, or indeed a panplexus avulsion. And if you'd like to read more about this, then you can check out our paper published open access in Frontiers in Surgery. We're testing this technology prospectively in adults with traumatic brachial plexus injuries in an NIHR-funded cohort study in Leeds, supported by many, many people to whom I'm very, very grateful. If you'd like to know more or support the project, then please do get in touch anytime. Thanks so much for listening.